Alright, today we're talking about 9.5. This is our last section in Chapter 9. I was mistaken when I thought Chapter 4, or Section 4 was. We are doing quadrilaterals, so we're going to talk about just some of the basic quadrilaterals, some of the characteristics of quadrilaterals. And as you'll see there are the two basic characteristics. A quadrilateral is just a closed four-sided figure. So triangles, tri means 3, quad means 4. So there's a closed four-sided figure. And similar to triangles, triangles have 180 degrees. Well, if you think about a quadrilateral, it can be divided into two triangles, which means it has 180 with 180, and it's 360 degrees. So the sum of the angles in any quadrilateral is always going to be 360 degrees. If you think about a square, it has 4 right angles. So 90 plus 90 plus 90 plus 90 is 360. So those are the two basic characteristics that we're going to talk about with quadrilaterals. I now want to have you copy down the basic definitions of some of these quadrilaterals. So we'll start here. These are 3 of them. So they're parallelograms, which is a quadrilateral. So it's a four-sided figure with 2 sets of parallel sides. So all we know about it, and I'll show you some pictures and figures of these in a minute, all we know is that the 2 opposite sides are all parallel. Then we move down to the rectangle. It's a parallelogram, which means it has 2 sets of parallel sides, but all of the angles are right angles. So we're adding that in there so it's clarifying it. So you guys all know what a rectangle looks like. Well, these are the characteristics that make it a rectangle. In a rhombus, not sure if you guys have talked about a rhombus before or not. It kind of has a diamond shape, but it's a parallelogram, so it has 2 sets of parallel sides with 4 congruent sides. So we know that all 4 sides are the same. We don't know, the angles are not the same necessarily, but the sides are all the same. And again, I will show you pictures of all of these things, figures of these, and how they all relate here in a couple of minutes. So if we move down, we're now looking at squares and trapezoids. So a square is both a rectangle and a rhombus because it's a parallelogram that has 4 congruent angles, which are all 90, and 4 congruent sides. So it has a little bit of both of those things. And then a trapezoid is separate altogether. So parallelograms, rectangles, rhombus, square, those all relate. Trapezoid is all by itself. It's a quadrilateral with 1 set of parallel sides. Okay, this black figure is a quadrilateral. So if you'll notice, it has the 4 sides. You can't see it all. But it is just going to be representing our quadrilateral. So this is a general 4-sided figure. So what I'm going to do is show you how these all interrelate. So I'm going to add in here this blue figure, which is a parallelogram. If you notice, it has 2 sets of parallel sides. These 2 sides are parallel, as well as the top and the bottom are also parallel. So as we're looking at this, this figure here covers a lot of them, but notice there are still some quadrilaterals that do not fit into that parallelogram field. This covers all parallelograms. Inside parallelograms, we have rectangles. Rectangles are a form of parallelograms. But notice there's a lot of blue outside of that that's not covered because there are other things that are parallelograms that are not rectangles. We also have the rhombus. So I told you the rhombus is kind of like a diamond. It has 4 congruent sides. So it fits inside the parallelogram, but it's not a rectangle. So those are 2 separate shapes inside the parallelogram. The last one that we have is the square. Remember, the square is both a rhombus and a rectangle. So it fits in both this one and that one. So this is kind of the breakdown of how they all overlap. You have your general category of quadrilaterals, which is the black. We then move into the blue, which is your parallelogram category. We then move into the red, which is your rectangle. But then you also have the separate green rhombus over here. And then finally squares move into both of those. If I had a trapezoid, I do not have one. If we had a trapezoid, it would be out here by itself as a separate category inside the quadrilateral pieces, but still quadrilateral, but just separate from all of the parallelograms. Okay, here's our first example where we have all of these pieces, where we have 78, 78, 102, and now we're wondering what this other angle is going to be. Remember that we're looking at what's the total here, and then we have a total of 360 degrees in the whole thing. So we're going to add up 78, 78, and 102 first. So we get 78, 78, and 102 first. So we get 18, carry the 1, we get 15, so we get 258. Well, how do I find what's left? We're going to subtract that from 360. Oops, wrong number. So we're going to borrow. We get 2, we get 0, and we get 1. So x is equal to 102 degrees. So it's very similar to what you were doing last night with the triangles. Now we're just looking at doing it with the trapezoids. And there also are going to be some where you're going to be asked to classify them. I've shown you kind of what each of them looks like, so we'll go over those a little bit tomorrow in class if we have to. But for now, most of what you want to take away from this is how to solve for those missing degree measures.